So, morning. Just a gentle reminder that I think our first homework will be due on Sunday, I guess, end of Sunday. So I hope you don't have any questions. You just need to submit the first page. The ungraded one, I mean ungraded means I just mean ungraded, so I'm not going to grade that. But if you have any question, then you can just talk to me to see if you need help on those. But I guess should be more or less okay. I mean, but if you do have problem, struggle a little bit, then you can email me, and then we can see how can we handle it. So the topic one is just to remember what we have been doing, right? Topic one is just trying to say this, right? When we have X, so the quantity, right? And the price, and this is the downward sloping demand curve, right? And assuming that the consumer is price taking, which is usually the case, and this would hold, right? And just to remember, what we found out is this would hold. This actually holds when the income effect is small. So when you're talking, that means when we look about a very particular industry in the whole economy, this has no problem. Okay, and we would derive the same for the firm as we do today. Is assuming the firm is a little bit different, is she is both the price taking in input market and the output market. In that case, we have this. So this is the goal of today. And the next thing to show is what you learn in the intermediate principal class, the producer surplus. Okay, indeed, suppose the price like this, right? Surplus. Okay, this part producer surplus is indeed the right measure. Okay, it's measuring profit exactly. So that is better than the consumer surplus, because consumer surplus is saying that it's also true for the income effect is small. But when income effect is not that small, it depends on whether inferior good or not, then it's not actually measuring the welfare we want, because we care about certainty, so equivalent variation or compensating variation. And that is consumer surplus in the middle. Okay, it's a good approximation. But for producer, as we saw today, it is actually exactly what we want to measure. It's exactly the profit that the firm is having. So that is a little bit different of what we want. Okay. So what I want to do is very quickly review what we have learned, and then we'll go continue, because I think last time we finished the first part we finished the production technology, right? 2 weeks ago. Last week we covered the cost minimization, and today the goal is to finish the profit maximization. And it will not be too much different from the you learn from the intermediate class. So I just try to be a little bit quicker because all the math actually is same or even similar, or you can say it's very similar to the consumer one. So I'm trying to skip most approved, but try to see if I try to explain some intuition behind, and we'll try to proceed to the next topic, equilibrium, as far as we can. I think at least we should be able to finish everything for this set of slides today. Okay. So just to quickly go back to this one, right? Just to emphasize that we just ignore everything in the firm, just treat firm as a black box that transform input to output without looking at the firm inside what's going on. Okay, and to look at how firm inside is going on, you need game theory. The fact that because the firm is exactly what, according to Ronald Coase said, it's a suppression of market. It's exactly opposite case of market, right? Market, how you solve the problem, rely on price. But in the firm, it's not relying on price, right? It's relying on the firm give an order, you do it. The boss told you to do it, and do it, right? So that's like exactly not allocation resources based on non-price measure, exactly the opposite case of market. Okay? And production is just transform input to output. And the way that we learn is like production plan. This is more general than consumer because the space you have is any positive and negative number is also emitted, where negative number means input, output is positive. Okay, and you look at Mascola, Winston Green, they would have this general form of notation throughout the text, but we are just trying to make things more easily, saying that we just focus on there exists an output function for each output. Okay, so I mean there's some assumption behind you can do that. Okay, so although here we just say one output, it is okay you have two different output, right? And you can assume that separate the two production functions are separable. Okay, so there may be some F, you can produce a particular Y, and then other say G produce another output Z, say. Then this is not a big restriction unless you say there may be a strong complementarity between two production process. Then you have some slightly issue when you handle those. But I guess unless you concern very complicated scenario, this is something that's fine. And here is the assumption that we have imposed on production function, which is usually we impose it because without that, there usually will not have a nice solution. So this is similar to what we assume for consumer. Okay, and usually this is a good assumption, at least for a short run. Okay, that is a good assumption there. So I don't need to explain further because this is only thing is this caustic concavity, which requires some explanation, which means that the average of the two is better than the minimum of the two, okay, averaging out. Or if you have a more productive production plan to the other inferior one, you mix them, it's still better than the worst one. Okay, the easiest way to think. And this is what we have assumed in consumer, but producer I think is more might be more reasonable, especially when you consider there are complementarity between inputs. Okay, so that is what it is. And I'm not going to go over marginal product, just differentiate respect to the input. Okay, marginal product. And here usually with this assumption we make, we will make the marginal product is diminishing. Otherwise, you would use that output to produce everything. So that is very natural assumption to impose. Average product, just divide the input, right? And the ISO quant is exactly same as indifference curve, the idea. Right? ISO means equal, right? Quant is quantity, equal quantity. That's what it means. And because of we assume F is monotone is in input, so that's why the ISO quant is always aligned for most of our purpose, right? So that's the line you have here. And the next thing is MRTS, but this is same thing as MRS, right? Just saying that if you change one input, how many other input you need to make sure that you keep the same output, right? So say basically this is the slope of the ISO quant. Okay, the slope of the ISO quant. If you assume F is monotone in this input, right? So that exactly the slope is, right? But if it's not monotone, then the MRTS is not well defined, right? Because it's not clear what do you mean by that. The next is return to scale. This thing is more, if you learn macro, that will be something they care a lot because they talk about often talk about economic growth, right? And growth means that inputs are or technology growth means that the input or the production function is indeed growing in a certain direction. And if you look at the macro case, they will always thinking about constant return to scale or decreasing to scale. Because if this is not the case, then the economy will actually have no steady state. You explode, just like because the economy keep growing, there's no end state of the world, and that's why you can't have the increasing the scale. But seems, as I said last time, recently the macro economists try to think that actually increasing return to scale might be the case to explain why rate of growth. Okay. But if you try to look at recent papers in Nature, the physics people try to think of the case all of the thing we have done is wrong because they thought that there's some what we call technological boundary or resources boundary, or we call planetary boundary, or which means that there's a limited number of resources in the world, so you cannot grow forever, or because of say there's limitation to the technology, just like the semiconductor, the microchips, right? There's a number of how small you can get is rather limited, right? Now it's like 1 nanometer, but you cannot go beyond that. So there's some limitation to the Moore's law. But anyway, that is what we have, and usually we assume this too. The reason is being that that imply the production is homogeneous degree less than 1, and because of this, F is concave, and F is concave, then you can see there will be solution to the profit maximization problem. Okay, or you only have, when you have concave, then you have a nice property for the profit maximization problem and also the cost minimization problem. So that is something that why we always assume this, okay, because this tends to be reasonable, okay, at least for most of the industry. There may be some industry doesn't fit that well, but this is a good one. Okay, not going to talk about this, but just to remind you, this is a 3 important example for production: linear production, just linear in the input, and Leontief, right? That's proportion to that, and this Cobb-Douglas too. Okay, so Cobb-Douglas is among the most important one. So you probably, if you try to work out for your model, Cobb-Douglas would be the good one, right? Just usually what you learn from the intermediate class, right? There's a capital labor, okay, that would be important. That would be good enough. And if you look at a lot of Dironacimo Group's paper when he tried to apply it to political economy, right? A lot of time it's just capital labor and also land to talk about historical development of I mean, democracy or non-democracy or middle class. I mean, that's how, right? The aristocrat control the land, right? The new middle class entrepreneur control the capital. People control the land, and that's how he used the model to explain how, I mean, capitalism changed from feudalism, right? At the end, you have capitalism, right? Because of the rise of middle class who control the capital, and so on and so forth. But I guess that no one is doing political economy, I guess. So that's why I think it's okay. This one is a little bit tricky, okay? And we call elasticity substitution. The reason we want to know this is just slightly tricky, just like the change in MRTS over the ratio of the input, okay? So this is not easy to see, but the meaning when you have 2 input is rather easy, just like how change in the input ratio relative to MRTS ratio. And but this saying that when this is high, the isoquant is flat, it's low, it's rather curved. Okay, how they substitute. And it's not easy to see how important it is, but only thing I want to say is this function, okay, has constant substitution. And I think we have said that in the consumer case, this function has a very nice property. And when you try to look at a lot of scenario actually end up with this one. So it's not just only you will see this in the consumer or producer, and actually this kind of summation, you raise the power and take a square root is a very nice index. And particular case, if you take, say, when you remember this case, we take rho equal to 2, right? It's just the Euclidean thing when you talk about Euclidean distance, right? When you talk about, when you learn math, vector space, right? Algebra thing. And this is you look at upper branches of economics, this is a very good, very good, a very nice property. But anyway, I guess I should not go into further detail, but what I want to say just in different level of rho, then you have different combination of the basic thing. So that means that what you should be thinking when you will use the CS, right, is you would be thinking that if you try your case in, you write your model, you try to see your model actually hold in coplugulus, your model actually holds in Leontief, your model holds in linear, okay, or your conclusion result is robust to this variation, then what comes to your mind, you should be doing the CES, okay? I do not suggest you try the CES first unless you think the math is good. I mean, sometimes it's more tedious, but you should try something very simple. And if all three cases would work, then you can go for the CES. So that is my recommendation. If you for your project for this class, if you ever try to work out something, then it would be you should try that. Okay. Cost function. Okay. So this input pi is a vector of W, and just here is the cost minimization problem. Okay. You just minimize the total production cost. Right. This is a vector. There's a W1 times X1 plus W2 times X2 and so on and so forth. Bigger than this one, right? And just to remind you that what this, right, is this exactly this guy, right? This is X1, X2, right? And this is W dot X, right? And what we have is isoquant. We want to produce this isoquant here, Q of Y, right? And we try to move this up and down until you fit it, right? So, so that is the assumption, and that's why we need this to be a nicely shaped. Otherwise, you don't have an interior solution, right? A corner. So that's why we usually assume a nice thing would happen. And we just basically borrow from what, because this is very almost exactly the same as the consumer, right? Because basically a consumer thing, right? So that's why all the proof will be similar, right? And in particular, this case, right, the wage, okay, will be equal to this one, right? This is the marginal product, and remember what's lambda here, right? What's lambda here? So just a quick question: what is the lambda? Can anyone tell me what's lambda here? Just try and look at M.Phil theorem. What's a lambda? Yes. So what does that mean in economics? Yeah, that's good. There's a Lagrange multiply, but what's it? So if you can't recall, let us go back to the. I mean, I think it's good to ask this question. Otherwise, it's very sleepy in the morning, and you have a long holiday afterward. So let's go back to here. Okay, it's good to check out whether you understand what's going on instead of telling you everything. So remember when I do maximization problem, okay, look at this question. What is the lambda? When you differentiate lambda, right? It's the marginal utility of wealth, right? What it is just like I increase 1 unit of wealth. I just change this guy. What is the optimal, at the optimal, how much utility you got? Okay. So can you try to see what is the lambda? Lambda. Okay, if you fail to see this, let's go to the, actually we almost cover this part. Okay, read the sentence. Extra cost of one output. Why? Look at this. Right? This is lambda is, you take the total cost with respect to y. So just change one unit y, how much total cost increase. Okay, so probably you can see why this is the case. Right? Because you employ one more unit of I, this is a cost. Right? This is what? Okay, I left you to figure that out. No one willing to answer what I'm saying. Okay, that's fine. I left it for you to think, but exactly this guy. You understand this? You understand that. Okay, ask yourself. Very quietly today. So here the first one is exactly what you learn from the consumer, right? Is the internal exchange rate and outside exchange rate, right? Because MRTS is how much for you, for the firm to say to keep the production the same, right? What is the ratio between them, right? And this is how the input and change, they must be equal, right? And this we explained last time how these two can be interpreted. Okay, I'm not going to talk about that. So go home and check yourself, explain yourself why this is true. Okay, I make it as exercise in your homework too, since no one answered me. So I make it as part of the assignment. One small question, explain this. Okay, I think it's easy. Okay, I hope. So the solution exists already because we have a strictly caustical concave production function, and this is followed directly from the consumer thing, right? So this guy is the conditional input demand. I think I'm thinking whether I have a wrong notation here, because I think let me think. I think I have a C for this one. I don't know whether I should add. I'm sorry, because I want to distinguish. Yeah, maybe you might be a little bit confused later. But anyway, the reason why I'm a little bit worried because you may confuse with the one in the later. Yeah, because this is conditional input demand. Maybe I should put a C. But anyway, let me think whether I'll update the slide if I think I need to change the notation. Because just like when you have Hicksian demand and Marshallian demand, then you have different functional form. So I'm not sure whether I should put a C here to signify this conditional input demand. Just matter of notation. I'm confused because sometimes I try to look at the notation from the one textbook, the many textbooks, then many different textbooks have different notation. I'm not sure what I have to follow. Let me think, and I will let you know which notation I'm using. But should not be confusing when you look at the exam or the assignment. Should be very clear. So maybe I should add C because to but I don't know what to do. But that is the function that depend on the input that depend on the input price and the output target, right? So that is the, and do note that this is a function because this is a unit, okay? That's a unique solution to that. If you do unit, you don't have this, okay? Have to be very careful. This is what we want. I mean, I think it's very clear, the same as the cost minimization, when Hicksian demand, the same thing, okay? And this is homogeneous of degree 0 in W, which means that you double the wage, that would not change your input, right? Because that doesn't shift this guy, right? Just say the same slope. Okay, and we have inferior input and normal input, where how things change according the output target, and do note that this part is different from. I think it's similar to consumer, right? You have normal good and inferior good, and input is also the same, okay? And usually when you look at these days the data, you will have for labor, look at the data, there will be two types of labor: the skilled labor and raw labor. Usually the skilled labor is normal input, the raw labor is inferior one, and they usually would be when you increase the production, right, you would basically replace raw labor by machine. Okay, as they actually what's happening right these days, right? There's like increasing automation, increasing machine, that raw labor actually being replaced. And you look at say for factories in China, small factory and big factory, right? And big factory will use a lot of machines, right? So that machine or skilled labor is more like normal input, but the raw labor you put inferior one. So I think that would be something very natural. And do note that this is only a local relationship. Okay, it's local. Go. Say at some point, say raw labor would increase with the output, right? But later raw labor would reduce when you further increase. So it's not a global relationship, it's a very local thing. Okay, so total cost function is just put the value there, right? And this is a unique and well-defined thing, okay? And so we just I think this is rather trivial. We just how you relate the input demand and the cost function, just put that there, the same as the consumer side. Okay, it's nothing new. So there's a lot of crazy thing goes on, but this is exactly the same as consumer. Okay, so I'm not going to go to the details of it. Okay, the only tricky thing is number 6, right? Number 6 is tricky, but we learn why it's true, right? Just like the graph there, right? It's like you keep the price, if you change prices, you keep the same bundle, right? It will be linear. But in optimal, then you can choose a better bundle. So that's why the optimal one would be cost lower. Okay, I hope you still remember that one. Okay. So here with average cost and marginal cost, and also the long run, short run. Okay, so here we have talked about long run, short run minimization and our causes, and this property of cost function. All these are actually when you talk about how you do in production, right? I mean, if you are operation management, those people would care a lot those, right? But for most of us, we actually don't care. Just it's a cost function, we just maximize. Okay, so and not sure how you would like it, because but this why we talk about this is because of the cost function. You try to give you the idea where you get the cost function. Okay, because when we actually do it, we just go to the cost function directly, right? So usually you don't go to the just like when we learn consumer theory, right? We just go to utility and just go directly, right? And advanced class tell you there's something background, that is the utility, the preference that drive the utility, right? And here we're just saying that when you actually work on problem, you almost always you start with the cost function, right? Very rarely you start with technology. Okay. Here trying to tell you that all the thing we're trying to do is trying to tell you, okay, the cost function is coming from technology. Okay. And technology is when you make any assumption there, then that will be the cost function looks like. Okay. And that's why a lot of effort, I mean, look at the textbook or what you learn immediately, talk about marginal cost, total cost, all this crazy machinery. Okay, I mean, there are a lot of things I don't think is very important because, but I don't know why textbooks spend a lot of effort in talking about this, and I just copy here in case you would see when you read the textbook. But I don't think it's important because at least for me, I never use those things. So I don't know how important it is, but when I don't really know because usually just okay, this is the usually okay, this is assumption we make and that's it. I mean, you don't do more than that. Maybe I have a quadratic, maybe you have a cubic or a more polynomial, then that's it. I mean, I'm not sure how better you can do, but okay, for the model. Okay. I hope that's clear what we have covered so far. But this thing is, I just very quickly skip so many things because this is exactly the same as the I can say almost exactly the same, almost the same because we assume consumer also cost concave utility, and that's why this is exactly the same thing. Okay, there's nothing new here. The new thing here is profit maximization. Okay, the reason that is different from utility maximization, as I said at the beginning, is the fact that a firm is facing two market, input and output, and we assume that price taking. Okay, and neither of these assumptions in fact is realistic in the real world. You know, I mean, of course, especially when you have a lot of firms has many market power. Okay, and especially next topic we talk about, especially firm is not competitive, at least in the output market. That's very obvious, right? Because we look at most of the thing in the world is not competitive, right? You feature a few firms that is very large, right? That actually make why you are studying business degree, right? If the market is actually competitive, what is use a PhD business degree, right? Because there's nothing new because everyone is price taking. There's no strategic element. There's nothing to manage, right? So that's why we have a job because of markets imperfect, right? The monopoly, we have oligopoly, right? That's why that's the case. Okay, but we first have to learn what would happen when the things are ideal, right? Just like the physics, right? You learn in the simplest case where there's no friction, right? No gravity, right? You just try to look at those things, right? Not where there's not Newton first law set, right? And you learn more and more. You have air resistance and all the things, then or friction or those kind of imperfection. Then you will know what to do, and this is exactly what we're doing. And looking at how when the firm is behaving competitively, price taker in both dimensions, you understand what the market power means, and that's what happened to regulation. Or if you want to make more profit for the firm, that's what you're trying to do, right? So you need to look at what happened. Okay, so here's the problem. Okay. So the problem is way more complicated than consumer, right? Consumer because you would just take this, right? As a little bit different, right? This is the maximization thing. You have to take P and W as exogenous. Okay, so that is the main key assumption here. Okay, because this is not controversial. The only controversial is W and P. Okay, and I think we just argue that the output market competitiveness, the P, okay, is a constant. It's a very big assumption there. But I also want to emphasize that assuming W is a constant is also a big issue. Especially when we talk about a lot of market your wages actually depend on how, or the input price actually depends on how much input you're using. Okay, especially when you consider when the market is a monopoly or oligopoly, right? There's only few firms are producing at the area. It means that actually there's a few firms that hiring the same people, same set of people, same set of raw material, right? So that would become an issue. Just like we consider the case, right? Just look at the problem of airline company, right? And actually in this world is almost like either your Airbus or Boeing, right? So when you try to increase your number of feet, right, or hire more pilots, right, you are competing with the same set of firm, right? And you are competing for those input, right? So that's why this is obviously a very strong assumption. And macro look at the macro 60s and 70s, they would happy with this setup. And I mean, recent 20 years, okay, they are not happy with this P. Okay, they think there's an oligopoly would be there to do things. Okay, and recently, a lot of paper on trying to look at W. Actually, I will have some paper working on that too. But recently, there are a lot of paper as well on working on why when W is not taken as exogenous. Okay, so that is what is happening right now, and that is very few paper talking about this. I mean, in macro, I mean, even in micro is less doing because they think that is a very similar case, but turn out to be from macro perspective is very different from labor economics. So the first thing to look at this problem is although it looks like very like consumer, okay, maximize something certain to certain constraint, but it turns out that this constraint is a trivial one because of the fact that F is monotone. Okay, so this means that the input are costly, so this one must hold at equality. That's why you can replace it to here. Okay, let me repeat the statement. I think it's important because F is monotone. Okay, so this must hold at equality. The reason is being W are positive price, right? Because input, I don't think they're negative input, right? So it must be positive price, and that will imply this must hold equality. And this whole equality, you can just put this guy to here, right? So that's how you get this guy. Okay. And that is the reason why. But anyway. So this is the thing, right? So that's also, I think I have a small typo. This would be bold x because x is a vector. So this would be the bold font x, but I don't think you would be confused, right? So that means that we have a unconstrained maximization problem. Okay. So this good thing is this is the first time we don't require Lagrangian, right? This is the standard maximization problem, right? Just FOC sufficient, right? You don't need to worry too much. The thing. Then also is look at this problem, you will see why we have to assume F is concave, right? If you take the derivative, second derivative, right? The SOC, the second order condition will be guaranteed if F is concave, right? Because let's see the optimal solution, right? So the optimal is this one, right? The FOC. When differentiate that, will be the price times the marginal product equal to the wage, I mean, the factor price, right? So the interpretation would be you increase 1 unit of input, right? I, and that this marginal product is how much output you can make, and because the firm is price taker in the output market, so they can sell at this price, and this is the revenue you can get by increasing output based by using one more unit of I. Right? That is the benefit of using one more unit of I. And that is the cost of using one more unit of I, right? So it must be benefit the cost, and that's it. Okay. And do I have SOC here? Yeah. The SOC, right? When we differentiate again, right? It just P times this guy, right? So that's why when we have concave of F, then you're done, right? Because it's naturally this, but this is positive, right? So that's you don't need to worry about that, right? So that's why when we talk about the F, why we need concave, right? So that's why we need the assumption of. That's why we justify. Remember this this slide. Okay, let's go back to here. Sorry, a little bit, jump a little bit. So why we need this one? It's concave is when we talk about caustic concave with homogeneous of degree from 0 to 1, we have a solution. Yes, there's a question. So when you don't have this, then there's some problem, right? Because when we have a perfect competitive market, okay, is inconsistent with increasing return to scale, right? So look at this problem, okay, right? If you're increasing return to scale, what happened is one firm would be making all the output, right? Because one firm increasing the scale means you scale up, actually produce more, right? So when you have perfect competitive market, then one firm will scale up as big as possible, right? Until there's nothing to bound, okay? So that's why in the classical economics, right, when we think about perfect competition, and the only way consistent is constant return to scale or actually decreasing the scale, right? And that was what people call classical production function, right? But if you are happy to accept the fact that firms are not behaving competitively, which is the case, right? Then we can actually use the idea of increasing the scale, right? I mean, if you assume F increasing the scale, you must be either making this W somewhat not exogenous, right? You change the X, then the price goes up, or you make the price a little bit different from that, then you are okay to use F is not concave. You can use any type of F will be fine. Okay, but you have to drop the assumption that P and W are exogenous. Okay, and yes, so any question?
Problem is that the equation matrix is negative divide,
right? Yeah, but yeah. So basically, you just assume this. But concavity is a sufficient condition. Yes. And you do note that this condition FOC, right? If you just take this, right, take I and J, right, and you divide them, it's exactly what you learn for cost minimization. Is it clear? Because you have P Fi Wi and P Fj Wj. You divide them, right? This Fi over Fj, Wi over Wj, right? And this is MRTS. Is that clear? So that's how you get this one. And this one exactly what you learn from the cost minimization, right? This is just to remind you again, internal exchange rate, external exchange rate, right? The same. Okay. So that's why we said at the beginning, right? Cost minimization problem is a sub-problem for this big problem, right? Because you have to solve the cost minimization problem first and put it there also fine. Let's see if I have that here. What I meant is this. Anyway. So I already argued that this would hold if concave satisfied. Okay, as you said, there would be a less restrictive one, but that is something we assume. Okay, and later you will see this assumption is not sufficient when we talk about more than one firm competing. So when more than one firm is competing, you need slightly more than that. Okay, but that would be something related to other cases. Okay. So finally, we have two function here. Okay, because of this, you would decide your input x. Okay, and also your output. Okay, output supply, output function. Okay, so because of when you solve this, you often may miss the case because when you solve the model, you always look at this problem, right? We just simplify the problem. So here I only get what is the optimal input there, but indeed, I mean, you also got the optimal output. Oh, I sorry, this is a typo. This will be x. Sorry, this will be x. So you also put it the f of x to get you y, right? So that's why this is how you get your answer here, right? Deciding on what the x and input and output, right? So the main difference is this output, okay, is based on prices only, not potential target. Okay, so that's why this is what we call the unconditional input demand. So that's why I was thinking whether I should put a C in the before to distinguish this is unconditional. Maybe I should. And the Y is a function as well, depend on price. Okay. I don't know. Maybe I should do it because it may be confusing to you if I don't do that. So these two and this output by function, okay, is exactly this one we want. This S, okay. That's what we're going to do probably for the rest of the class is trying to talk more about this one. Okay, and we try to show you this is upward sloping. There would be the assumption we need to make by this is assuming F is concave, and F is concave will be sufficient to derive this. Okay. So there's some property from this thing, but I don't think it's very important. The first one is not very surprising. It's just like very same as the consumer, right? Just like you double the price of everything, there should be no change to everything, right? Because your input price, output price are double, right? Then for the firm, doesn't actually make a difference, right? Why it's the case? Because that is coming directly from the optimization problem, right? Here, if you multiply this maximization problem by constant, right? The same thing happens. There's no change in the solution. Look at this problem, right? You multiply by k, or by lambda, you can take lambda O, right? So that is the reason why you have the first line, okay? The second line, the third line is very important, right? But I don't think we offer a proof for that. But we can just, but the proof is actually very similar to the consumer case, okay? And what is surprising here is, okay, the following, this guy, okay? This is the important thing is the output is in non-decreasing or increasing in the price. This guy, okay? So there's no income effect, substitution effect. The working opposite case. In fact, in this particular setup we have here is it is always increasing. Okay, there's no given good, there's no given paradox. So that is the main difference here. Okay. And I think this last one would be rather trivial, right? Just like this is nothing deep here. Just like if the input, right, is more expensive, you cannot consume more, right, at optimal, right? Just like when, I mean, there's a also there's a very straightforward interpretation, right? There's not another demand, right? Demand, like the price increase, you should reduce your demand for that same idea. So there's no paradox for that one as well, right? There will be paradox. There might be paradox in demand theory, right? There we have to consider income effect, right? But here, this two, that's why it's important, is because that the sign is already fixed, different from consumer. Okay. So that is the key thing. I mean, the first one I think is trivial, right? This two is very important. But the proof is, I'm not going to prove it, but just to emphasize, the actual proof require you to use the Hoteling's lemma because of this X and this Y, in fact, by M.Phil theorem, they are derivative for the profit function, which we introduce later. And because profit function is concave, then these two are naturally the shape we want. Okay, so but I'm not going to prove it, but instead I'm telling you one interesting fact. Okay, so that's why I confused, because I use C in the notation here. So this is the demand for input when we talk about the profit maximization problem. Okay, this is the input when we talk about the cost minimization problem. Okay, profit maximization, cost minimization. Okay, and you can replace this by the output function here. Okay, so these two are the same thing. Okay, this is change in the two price. This is in the price, but change two prices will change your output target. And so that's what I meant. The cost minimization problem is a subproblem. Okay, because you can solve it, right, in this way. Okay? If I know how I change my output target, right, that the cost minimization problem can get you the what you get in the profit maximization problem, right? And in that case, you take the derivative to this one to the wage, right? You can see same as the consumer case. You can change your first impact is cost substitution effect, and second impact is you change your price, actually change the output target. So that's why it's output effect. Okay. Turn out that actually this negative is also negative. Okay. The proof require, actually you can mask collect Winston Green or Randy that you can prove it. But the idea is based on something we talk about the next slide. We need to talk about the profit function, and then you can easily prove it. Okay. But I'm not proving here because I don't think you would interest in the proof anyway. So just say very quickly after this break. It's this guy. Okay. We have a Cobb-Douglas production function. Let's see how we can get the X and Y, right? So that is rather standard. Okay. The fact that you take a derivative, okay, and you solve the model, give you this something rather ugly looking form. Okay. But I want to draw your attention. I mean, you can forget about the notation. I mean, probably you do something similar for your assignment. Is price and the input are inversely related, right? Hopefully you can see that, right? And you also, this is inversely related with this wage, or input price would be, right? Okay, is that clear? Is that clear for this one? And we also have the same happen for the Y. Look at the Y, okay? When P increase, some problem. there might be some issue here because Y is not increasing in P. Maybe a typo. I will check because P should increase with Y. Maybe I have some typo. Okay, I'll check out what's wrong with this one. I think I have something wrong in this solution. I'll check out and get back to you for this one because according to this one, Y should be increasing P, and there must be something I miss somewhere here. Yeah, maybe. Anyway, I'll check out. I'll tell you. I'll update slide accordingly. If there's I think there's an issue, but that would be that. Okay. So after the break, we talk about profit function, and then we will be finishing this set of slides. Okay. I'll check that out and get back to you on this one. Okay. Let's have a break of 10 minutes, and so resume at 10:37. Oh, I know. Should be. Yeah, some typo. That's right. I handle that.
The P has 1 equals to dot dot. What is the definition of P?
Price of the output.
It is condition of the
So some of you ask me why P is negative here. I check it out. I mean, I think there's some typo here. Maybe just P should be. I don't know. I update it and let you know. Okay, I'll update. Probably not today, maybe tomorrow, because today a little bit busy. But I try to make sure that it will be correct. Okay. Maybe over the weekend I'll update. Okay. Just let me know that. So what is left here is just this profit function. Okay. And this profit function is nothing particularly new, right? Because just basically you just put the output supply and the input demand, put it there, then you get the profit, right? Just based on the prices, right? So, and this is nothing new, but there's some property here. The first one is being, if you double the prices of input and output, that you just output double your profit. Okay, I think that's rather trivial, right? Because just you double this, you take it out, the same maximization problem, right? Lambda P and lambda W, just put it out, nothing changed in the optimization. So that's why that's what you get. The second one, I think, is also not trivial, right? It's just like the output price goes up, then your profit must not decrease, right? And your input price goes up, your profit cannot be increased, otherwise it's suboptimal. Okay, so these two I don't think you need proof. And this also the same is M.Phil theorem. I think is I don't think we need the proof, because just you differentiate that, right? Respect to P and respect to W, right? Just to remind you what M.Phil theorem is, it's just like you can forget about the second order effect. Just think about the first order effect. Okay, just the total differentiation in that particular case is same as the partial differentiation. So that is the interesting thing of the M.Phil theorem. So I think we have this output demand function, this problem. I guess maybe I have some mistakes, so let me skip it. I make sure that this is correct. We can talk about this next time. So lastly, I want to talk about this one. Is the profit maximization you can read as, right, this P of Y times Y, actually CWY. And in this particular case, right, you decide Y instead of X. Okay, you decide your output target. Okay, and in this particular case, is P can be a function of Y. Okay, you increase the Y, P might change accordingly, right? And when the firm is facing competitive market, right, that P of Y is the constant P, right? And later today we will see, when we talk about monopoly, when other things, P is a function of Y. But for the case we talk about today, P is just a constant, right? No matter which Y you have, P is constant, right? So that's why usually this is the way you usually do the model, right? You just like, what is the demand function, right, or the price function, and you choose the output, right? Because you seldom talk about input when you talk about the firm. It's subsumed in the cost, right? Just to stress what we're doing here, okay, is okay. In this one, okay, there's no production function at all, right? Even production function is gone. Okay, what you will left is just a cost function, and that cost function will summarize everything we need. Okay, so that's why you can see one of the big reason why in the principal class or intermediate class they focus on cost function, because cost function is already summarized the optimal thing, right? Because this cost function is not the standard cost function, this is the total cost function, right? So when you have the optimal cost function, not the original one, right? Because the optimal cost function comes from optimization process, and this function, right, is already input here. Okay, once you have the input here, there's maximize over the output target, right? And that is the reason you have to be very careful, right? This is not the ordinary cost function, okay? And this is usually you would work on, okay? Although we do so many things, and usually this is what you end up with. And to remind you again, this is a total cost function. Okay. And usually this is if you write in this way, okay, and you took a differentiation of this. This is the first part, marginal revenue, right? This is marginal cost. This is standard way you consider the firm optimal output, right? It's a marginal revenue. And in this particular thing, right, we have dp dy, right? And this guy, right, will be 0 when firm is competitive, right? That ends up what you have is price equal to marginal cost, right? We'll talk about that very soon, but this is what you see from this one already, right? When firm is competitive, price equal to marginal cost, right? Of course, we argue a little bit more later, but when the case is the firm is not price taker, you will have marginal cost equal to marginal revenue. Okay, this is the part there. Okay, so that is something that you have to look carefully, and this is the SOC is rather simple. There's nothing new here. Okay, so few more slides. I don't think it's very important. The first one is called elasticity of demand. So you differentiate the output of a P. Okay. So this is what you have. Okay. And do note that why this is called elasticity of demand, because here we have P of Y is coming from the inverse demand function. Okay. And of course, when you have a perfect competitive market that's a flat, then you don't, this thing are more or less redundant, right? But when you're facing the market that's not perfect competitive, right? This guy will be meaningful, right? Otherwise, this is always 0, right? Because when you have perfect competitive market, there's a constant thing. Okay, so we'll talk about this more in the next set of slides, next topic. But this is how people define. And you may ask why we care about all this thing. And one of the reasons you do this is because later you will see this elasticity, okay, is measuring the market competition. Okay, and this market measuring the market power. So that's why economists care about this, because they can be measured, they can be estimate, and you can looking from this, you can infer, if you make further assumption, you can infer how competitive the market is. Okay, so that's why they care. But I think no one in this room would do that, so I think it's okay. But I just put it there because we'll refer to it later. Okay, and okay, just to give you the reason why they care about this is because you can rewrite the marginal revenue as the price times this guy, okay? And or you can rewrite the following. You can rewrite price minus marginal cost is equal to inverse of the elasticity of demand. So this is exactly what they are doing here. Okay, why the macro people care about this? Because they care about this markup. markup, you can see if the market is perfect competitive, right? This P should be equal to MC, right? Why P equal to MC? Just go back to here, go back to here, go back to here, right? This guy is 0. This will be this. Right? Equal to MC, right? So the markup exists because the demand is downward sloping, right? And later, actually, you will see this markup is closely related to how competitive the market is. Okay, this markup is something people care, and people care about this is because how in this particular model is related to this. But if you have more than one firm competing, then you will be something related to this as well. Okay, so in this particular case, you can see the markup is can be estimated from elasticity of demand. Okay, because why this is good? Because look at the supply. Can you estimate PC? Probably not. You can estimate P and P, right? We can estimate AC rather easily in the data, right? Look at average cost, it's easy. Marginal cost will require to ask the firm to do many things, right? But if you think they behave in this way, you can estimate this elasticity of demand. Okay, you probably ask how to estimate the demand, right? That's very simple. Look at how people demand. Look at the price. Take some assumption there. You can just take the log on both sides and differentiate, and you can get, right? I mean, of course, you have some endogeneity issue, but assume that away, then it'll be easy, right? So that's why when you estimate this, you can get a markup, and the markup is very important in macroeconomics, and because nowadays there's a big literature talking about markup actually fluctuates during the economic recession and boom. So actually markup fluctuates that drives the economy recession. Okay, and yeah, that's the I think the cyclical markup. Okay, markup shock. They call markup shock. And okay, so that is very important, but that's why I put it here. But I guess no one is doing the macro, so I don't know. Later, when you see the imperfect competition, then you will see this part is important. But for the moment, I think it's okay. But just let you know what the markup is. Remember this. Sometimes this is called absolute markup. This is called relative markup. This is absolute markup. This is relative markup. And this is important when you do macro, but no one do macro anyway. So the rest of this I will be rather quick because this is nothing new. But if you fix some factor, that becomes Sauron point function. Okay, and just to remind you again, what is the fixed, what is not fixed? It's artificial. Okay, when you think short run, there's short run. When you think long, it's a long run. Okay, when you think about you're making a decision, okay, in the case that there's some factor that's not changing, that is fixed. That's short run. Say suppose I'm talking about today, whether it's raining, okay, and I'm a guy who sell, I don't know, fruit on the street, okay, then if raining, probably no one is going to buy, right? Or there's someone near the MRT station, someone is buying frying smoked tomato, potato, those kind of stuff, right? If raining, no one come to buy, right? They talk about short run. If I think about I'm not going to our business, whether today I'm going to work or not, it's a short run. I'm talking about whether I change my occupation from selling potato to maybe selling I don't know, umbrella, right? Orange juice, whatever, right? Then in that case, you talk about long run, right? So short run and long run is just artificially. We talk about what are you thinking? How big you're thinking? Okay, it's a scope of decision. So it's very artificial. Anyway, this talk about short run profit fund, but nothing deep, right? Just I fix something, just derive it. Okay, there's nothing very deep in this case. Okay. The only thing why this is deep, only useful, is because when you make decision in the short run, you just care about the short run cost, right? Because when you learn the cost function, right? This is the thing you care, but when you actually do the maximization problem, you're not changing it anyway, right? You can take this guy out from the maximization, right? Because this is fixed, you can take it out, you maximize this guy, okay? So that means that when you talk about what is your profit function, okay, what is the your optimal production, right? Is the price equal to your short run marginal cost? You ignore your fixed cost. Okay, so that is the main thing, right? Because usually price equal to marginal cost, but now you only care about short run marginal cost, right? That is the undergraduate econ tells you, right? That the price can be substantially below the long run marginal cost or long run average cost. The reason is being that you forget about the fixed cost, right? Why you can imagine why sometimes firms are selling at very low price. For example, remember in those days where the oil price, the crude oil price go to negative, right? You would imagine price always positive, right? Actually, there's a research paper telling that in the US, the price of electricity when it's a good day actually goes negative because there's no free disposal. So you have to get the power to somewhere, otherwise explode, right? So to pay someone to get the things out, okay? The reason is being this, okay? Because there's a cost, of course, to generate the power, but in the short run, you don't care about those, right? To make sure that this thing will happen, okay? Here we still have free disposal, right? So that's why price is always still positive, right? But when you don't have that, then you have some issue here, right? Because the short run cost, right, can be negative, right? In those cases, that's why negative price. But anyway, that is what it is. And next, this is something you know very well in the intermediate, I think principal class as well, is when you have a shutdown condition, right? When you have not working, right? For those actually coming from out of Hong Kong, would be surprised that Hong Kong business keep going on every day, almost single day, right? If you happen to go to Europe or you happen to go to other places in the world, Europe actually don't work on Saturday or Sunday, right? I mean, in Europe, even the shopping center is not working on Sunday, most of them, right? You may be surprised because Hong Kong Sunday people go out and have fun, right? But in the Europe, actually Sunday, no one actually works at all, right? So that is rather surprising. I mean, there's some other issue, but why? Because I don't know, but at least never shut down, okay? Because one explanation is because in Hong Kong, the rent is very high. Oh, does it surprise you? It's okay. The fixed cost is very high. So the marginal cost, the marginal variable cost is very low. Okay. So the price is higher than the average variable cost. Okay. So variable actually means short run, otherwise there's no variable, right? In that case, when I take this thing, right, this part in Hong Kong is very big. Right? So that's why when you take differentiation, you never shut down. Okay. Even though it's not that good. Okay. Do I need to go with the proof? I think that should be fine, but just quickly. So price equal to price times your output, right? Minus your average variable and average fixed cost, right? And you shut down, this is zero, right? You pay this much. If you if no shutdown, as long as this is bigger than this, right? So that means that the price is bigger than your average variable cost, then you would goes on. right? So as I said, if you have a lot of the fixed cost is very high, right? Then you don't want to shut down, right? Because you pay the rent already, right? So just the you compare, you do the business, you just earn some profit, right? And enough to cover the variable cost to do it, right? That's why you will see a lot of business actually running a loss for half a year before they gone out of business, right? You can see why you go to the shop, that's very big, no one there, the shopkeeper still fighting with the mosquito for half a year before they go bank, before they go out of business, because they have signed a contract, have to pay the rental, right? There's no way they can get out, right? So as long as they can earn something, cover the variable cost like the lighting and the thing, then they will still do business, right? So that is the reason why here. But I mean, probably everyone knows it from the principal class. So, but this is just a mathematical proof for that. But I don't see the reason so complicated. And there's always apply function. The same thing here, just replace everything by that. And there's, I don't think there's anything new here. Okay. And this is nothing new, but when they talk about the long run supply curve, also you have this, and short run also have the same. I'm not going to talk about this because this is just the principal class. I don't even have a new proof for that, so I'm not going to talk about those. Okay, so I think I should spend time on the last one. Okay, is that okay? Do I need to go over this one? Do we need to go over this one? Okay, no one say anything, so I can skip. Okay, welfare. Okay, so as I said, this is much easier. Okay, so the firms only care about profit, so his welfare is just his profit, right? Same as consumer, right? His utility is his surplus, right? That's why we are talking about not his demand, but his. That's why we have to distinguish, right? In the consumer, right? Consumer case, consumer surplus, right? Actually, it's not a good thing because it's not measuring utility, right? So that's why you have EV and CV, right? Of course, turn out that CS is always in the middle of CV and EV, so that's fine, right? And for the firm case, the producer surplus, we can measure easily when I talk about competitive market. Okay. Okay. How is the case? Okay, this is always definition, so that's not a issue because calculating profit is rather simple and it's measurable. Okay, at least from accounting point of view. Okay. But do note that okay, there's some slightly issue you might forget is accounting profit is not economic profit. Okay, you go deeply then because there's an opportunity cost of entrepreneurship, so on and so forth. Okay, but that is economics, right? But actually, when you look at the data in the real world, actually people take the same. Okay, but you have to know it, right? You take this class, you should know the profit here is different from accounting profit when you see the accounting statement. Okay, you have to, but more or less, I think for calculation in the real world, I mean, all the empirical paper just take the accounting profit as the economic profit when you do the data. So, but I just let you know they're different because the thing is now what we need is why the producer surplus is exactly this area. This coming from the M.Phil theorem. The differentiate profit function is to the price, it's just the output. Okay, just go back to here. You try to convince you this is right. Okay, you differentiate this with respect to price. That's why. Okay, this doesn't have P. Okay. Okay. Of course, remember actually change the P, right? You should change X and Y, right? But envelope theorem tells you you cannot forget about the second order impact. Okay. Let me repeat the statement because it's so important. Okay. Suppose in this maximization problem, you change the P. Okay. You change the P. Suppose you understand from economics, you will change your output target Y, optimal output, right? You also change your input X, right? So in terms of calculus, right? You should see this thing, right? D pi dp should consist of 3 parts at least, right? You should have partial pi, partial p, plus partial pi, partial x, and x through p, and partial pi, partial y, and you should have these 3, right? So change in p will change in x, change in p will change in y, right? And x will indirectly affect the pi, right? So this is called indirect effect or second order effect, right? Or indirect, right? But the envelope theorem tells you that you can ignore this. The reason is being that under the first order condition, right? This is 0. So that's why you can forget about it. Is that clear? I mean, this from envelope theorem. Is that okay? I mean, since I think you guys are much more mathier than I do, and that should not be easy. I mean, that's not laughing because you do calculus every day, then much better than I do. I mean, I seldom do it anymore. Yeah, so this is the reason, right? Just same as this, okay? And you differentiate partial differentiation just y, right? Is that okay, right? This is just that, okay? And it's very natural if you have the output price is 0, your profit is 0, right? So that's why integrate from 0 price to up to this guy, right? That's why. Price 0, you just integrate. Because the P is here, so you have to look in this direction. This is a so you ask why this is the area, okay? Because look at the Y and P, right? You should be talking about this area, right? Normal integration, right? If you integrate dp, right? 0 from P star, right? But we are just swapping this graph, so you have to look this direction. So that's why you get this one. Sorry? Calculation what? Oh no, just the standard integration, but because you put the P here, Q here, just you have to look at the other dimension. But anyway, so you just swap X and Y, the same thing. Okay, so that is why the producer surplus is just the area between the price and the supply function. Okay, so just to compare and contrast, when a consumer, this is not the case, right? Because we look at when intermediate thing, right? This is we call consumer surplus, this producer surplus, and we're done, right? And what you learn is partially true, right? For the firm, that's fine. The profit is exactly what you're measuring from the producer surplus, but the consumer surplus is not entirely exactly correct. It's true when you talk about if this is the if this is the income effect is not there, this is the Hicksian demand, then you're right? But it's not the case. But of course, in the real world, no one cares. People just do consumer surplus anyway. But you have to notice consumer surplus is not exactly what we want. Okay, so I hope I convince you that you would calculate that. You know how to calculate PS and CS. And do note that when you don't have this, it's only true again because this is only true. It's true because you do the area. Look, this is already true. There's no sorry. This is already true. Okay, there's no problem for this one. Okay, it's already true regardless of whether the firm is competitive in the product market or input market. That's no problem. Okay, it's always true. Okay, by definition. Okay, but this one is only true when the firm is competitive in the output market and input market. Especially look at this problem here. How you get this is through this one, right? So, but this is assuming that P is exogenous, right? You can get that easily, right? If not the case, then things become very complicated. Okay, so this is only true. We only use this when the firm is behaving competitively. Okay, so that's why we no longer emphasize this calculation when you don't have a competitive market, right? You always calculate this one. Okay, so you always start from this one because, as we said very soon later or last class, we said when we have this output supply function, this wing only exists or usually is only well defined when firm is competitive in the input output market. When there's oligopoly or oligopoly more than one firm competing, right? We'll talk about later soon. Then you don't have this output supply function. Okay, is that okay? Okay, so I mean it's kind of defeating because we learn a lot of things, but it doesn't apply to many scenarios for the firm. Because when you have more than one firm, the interaction game theory kicks in and things are very complicated. Then, but we still have to follow it because a lot of interesting case you can still use it because a lot of time you may just assuming firm are competitive one side or the other, right? It's very difficult to make a model when you say firm is a player in the input market and also in output market, then your model is very complicated. Okay, that go back to the idea where how you write a model is you cannot make realistic in every dimension, and your model will be out of control. Okay, you can only study a very minor problem at one point. That's why you have to sometimes you study consumer. Very often you assume the price is exogenous. When we study firm, we make sure that the market is a little bit, I mean, competitive in one way or the other. Okay, and we make some assumption to simplify, right? We hear why we make this assumption because we make our production technology is very complicated. We allow very complicated combination of inputs, so that's why we make our life easier in this dimension. But later, when we assume the cost function, later you see most of the model we just directly assume what is C of Y, right? We just assume directly the total cost function, right? I just here later you see, all right? We have just WY, right? This is something you will directly assume in the future when you calculate. And in that case, you can relax ourselves from other dimension, right? So that's why I study cost in my same problem. And this is common cost in our same problem, right? So once you have this, then you can just make your making more complicated thing. Okay. So just when you cost that CWY coming from this guy, right? Right? And this is something you usually assume, right? Because we can't go to this guy easily, right? Because this only for this context, we assume perfect competition, okay, which will relax now, okay, after this set of slides. Any question? Of course, I will release the assignment 2 after you're done with assignment 1, okay? 2 weeks again. Again, I make easier, okay? Same easy because you have this compared to last year, you have a project, so that's why I make it easier, okay? Any question? After the break, I will talk about equilibrium. So we will just give me 1 minute before the break. So what we are going to do, okay? Actually, this again is a very huge topic, but we don't have enough time to cover so many things. So that's why we all think we are rushing, but it's always hard. So what we are going to do today, probably should be hopefully can cover, is actually perfect combination is already we have, okay? We have supply and demand, okay? We just have to combine together, okay? That's the first thing we do, okay? And second thing you do, we try to look at the case where the firm has some market power. We look at monopoly, where in that case supply curve doesn't exist, okay? And we look at Conlon-Bertrand and monopoly competition, and all of them actually also don't have supply curve, okay? So if you slightly relax the idea the firm is price taking, then supply curve is gone, okay? But luckily the demand curve can be still there, okay? So that's why we just relax one thing, just take away the supply curve, okay? And this is one part. The other part, general equilibrium, oh, that is something very complicated object, okay? And what is this thing? General equilibrium is trying to understand, do we have equilibrium in the real world? The reason is being that when we talk about supply, right? Supply is, the firm is talking about looking at the input market, output market, right? So the thing is exogenous given, okay? There are many input, many output there. Then the problem is, do we have a system such that the price are stable in the way that there are no excess demand, okay? Because with demand in one market, right? Demand and equilibrium in this market will require equilibrium in another market, input market, output market. All the markets have to be equilibrium. The problem of general equilibrium is such whether this equilibrium exists, okay? That is math people really want to work on, okay? And for those who are not working in finance, okay, you don't have to worry about it because actually in economics, I hate to say, but very few people are doing that, okay? And actually my advisor is doing that. My advisor is doing general equilibrium, okay? You can, one was actually my advisor, I follow the tradition of Arrow de Brue, so that's my advisor Arrow de Brue, but which is one of the founder of this approach. I hate to say no one use it, but at least very few people are using it anyway. But when you do finance, okay, asset pricing, and actually that part is you learn general equilibrium, and with many complicated things there. And I guess unless you're and you learn those in the finance class, so I just talk in a very simple version of that. Okay, so I'm sorry if you do finance. I mean, I can't go more, but I should go more as I follow that tradition, right? But I cannot do too much on that. So let's have a break and then come back. We will hopefully finish first half of that. Hi. So after very intensive producer, so I think today we cover the partial equilibrium would be very relaxing because most of them you should have learned in the principal class or in the intermediate class already. Okay, so I just put everything in the perspective because we'll talk more in game theory in more detail. Okay, and do note that these things are actually before game theory appears. Okay, so we'll use some idea of game theory, but we are not exactly going to game theory yet. Okay, we'll talk about uncertainty, then go to game theory. Okay, so let's talk about the first item, perfect competition. Then exactly this guy, supply and demand, we get equilibrium. Okay. So to focus on the case, we focus on the case that only one good. Okay. And we hold them constant. Okay. That is exactly the idea of partial equilibrium. We just focus on single market at one point of time. Okay. So that's why general equilibrium would say everything will be determined in the equilibrium. Okay. So we take everything exogenous. Okay. Then is what the partial equilibrium focus on. And so the price of the good is P. And by definition, what we're trying to do is we're trying to find how the P adjusts. Okay, the price adjusts. No one decides P, but this P will be the outcome of our model. Okay, it's not affected by anyone. Okay, but is in aggregate, this P is determined by everyone. Okay, just like the stock market. Okay, no one is able to move the price, but in aggregate, the price will be set such that the demand and supply kind of cancel out. Right, it's like equalized. Okay, so that is the key of this model, right? And that is underlying why we study economics in the beginning, at least classical economics, is trying to see price is an allocation mechanism. Okay, price adjusts such that the demand supply equalize. Okay, that is the distinction between price mechanism and non-price mechanism, right? In the firm, right, that's like how demand supply, just like the boss said, this is the case, right? There's no price to adjust, right? No, not telling you who do this job, who do the other job, right? But in the market, it's the price adjust, right? If some job people want it more, okay, price goes up and then more supply comes in, right? And so on and so forth, right? If there's the price is said that it's too expensive, no one want to buy it, the price go down, right? So that is the main key, and you can say this is almost like the main argument comes out from Industrial Revolution, right? Industrial Revolution comes in, right? And in that case, market become more competitive. Why? Because in old days, right? Every people is in a very small town. Only a few people is a few seller, right? A lot of landowner, right? Owning certain kind of land, right? They're lord, they're nobles, right? You can only trade with them, right? They have all the land from their father, their ancestor, right? They own all the most of resources. They set what the price, you have to buy it, right? But Industrial Revolution, what happened is you have mass production, you have train, your transportation system, people can move around, right? That means that no one is able to control the market. Look at the US, look at China, right? Even if you are monopoly in one province, right? You still have to compete with someone outside, right? And also labor is more mobile, right? Even in China, right? Only recently they canceled the kuko thing, right? Before that, it's illegal to move around, right? If you look at the Japan, during the feudal society, right? You cannot just leave your own place. You have to stay there forever, right? Look at Ming Dynasty, right? If your father is a carpenter, you are the carpenter. Your father is teacher, you're teacher. Okay, there's no occupational choice. But once Industrial Revolution comes in, and this kind of old social link, social elastic breaks down. So that's why people think about, okay, there's any way that how the market adjusts, how the market comes out. And that comes to capitalism, right? So that is the main thing, okay? And so that's why this is the main core of economics, right? That's why every economic clause would talk about demand supply, right? Because this is answering one single big question, right? How the market adjusts. Sorry. Okay. So it's very surprising because price by itself is already enough to solve a very complicated problem. You can imagine, right? You can talk about if you don't talk about the market, right? You have to talk about a planner, okay? Have to say how to coordinate, okay? The consumer and producer, right? Because the planner have to know what the consumer utility is. The planner also let you know the production technology of the firm, okay? And solve this joint maximization problem, right? To make sure that some objective is being achieved, okay? And in this particular model, probably you also know it, right? When you have demand supply, at this point, the what we call welfare, which is sum of the consumer surplus, total surplus, is maximized when market is at equilibrium, where the demand supply cross, right? This is what you learn in the intermediate class, right? And you still remember, right? No one remember. Okay, fine. But we'll talk about that later. But that is the main thing about the market, right? Is the market just the price adjustment itself can achieve this equilibrium, this good outcome, such that this total welfare is maximized. Okay, and it doesn't require a planner to coordinate things. Just the price is the coordinate, is the communication between buyer and the seller, right? Just the price only. I mean, if you have a planner, then in order to achieve this or other objective, he may desire, he had to know many things in order to maximize. So that's why planning economy has some issue, what we say, information extraction, right? How you get information from people and they lie, right? And that actually the game theory, mechanism design would have to solve this problem, right? How to get the information from people, right? Because they tend to lie, right? Because if you say, I give you certain wage, then they may not working, right? Just like in the old days, right? In the 人民公社, right? In those cases, people get the same wage regardless of whether you're doing the thing, then you're not working, right? Suppose I say, regardless how you get the exam, everyone got A, right? Then no one study, right? So although you don't care about A or A minus in our graduate class, right? But still some people would be happier, you would study happier, you want to get A with an A minus. So study a little bit, right? So there's some incentive to work hard, right? And there's qualifying exam to make sure you work hard, although you should be self-motivated, right? But okay, I hope that is something we want to do, okay? And the general equilibrium is trying to show you this idea actually holds when you don't control just one market. Okay, let me repeat the statement. Okay, here the market maximize this too, right? So we are trying to say in somewhat related idea, when you have many market, many goods to buy and sell, right? In that case, this concept of maximizing welfare, some kind of this, also continue to hold. But anyway, I think I have enough background to tell you. Okay, so just some math, but I don't think that would be deep because it's just notation. Okay, the M consumer. I don't know. M or I? I, okay, that's I consumer. Sorry, I consumer. I consumer, and each has income of yi, okay? And we just assume directly that the Marshallian demand is py, okay? Price, and there's only one good, so there's only one. It's not both, there's no vector. There's only the price and his income. Okay? And we use the superscript to represent the guy, and the subscript represent the good. But here's just one good, that's fine. But when you have more than one good, the subscript represent the R is good. Okay. So this the superscript is the guy. Okay. The subscript is the good. Okay. So this case we have both y is the vector of the income. Okay. So here we define one thing is called the a little bit slightly careful. Okay. It's careful. What we call market demand. Okay. Market demand is okay. At the same P, you summing all the guy. Okay. So when you try to look at this, okay, when you, I don't know, there's a common mistake when you teach intermediate micro or the undergrad, right? If you try to draw this diagram, right, is P, and then this is Q, right? And you would say, okay, this is demand function for guy number 1, right? This is demand function for guy number 2, right? And the market demand is adding them together, right? The undergrad may think, okay, this is the market demand, right? So what's wrong there, right? Note that you are adding, fixing the P, so it's not horizontal add up, rather than it's not vertical add up, it's horizontal add up, right? The market demand is this one instead, right? Just for each P, just add these two up. This is A, this is B, and this is A plus B, right? Is that clear? Because the reason why it's not going up, because when we draw this graph, it's inverse. It's P and Q. If you draw QP, okay, then it's really adding up. So make sure that because the reason is a misnomer, because the thing is, this is not exactly demand curve. This actually should be inverse demand curve, right? Because the horizontal axis is P, it's not the demand, it's inverse demand curve. So that's why when you add up, you just add horizontally. Okay, is that clear what I'm saying? I mean, that is very important because I don't know, at least for the same P, add up all the constants. Okay, so in this case, what we said, the aggregate demand depends on price, aggregate income, and distribution income. Okay, so something is often missing when I talk about macro, is recently become more important, is in old days people care about price and aggregate income. Okay, but it's very important recently people notice is the distribution income is very important. Okay, but that's why there's a lot of research on economics about inequality, how money is being distributed, right? And that is very important, and especially when we talk about marketing, right? Talk about demand. This is a very important idea. How the distribution of the income actually affect the demand, right? So is there if the rich guy give the poor guy a little bit money, right? So the aggregate income the same, but the distribution is different. Actually, it would affect the demand. Okay? So that's very important thing. Probably you have to be worried. Okay, I can tell you one story. Probably you guys would not be born at the time, so I'm old enough to say this because in the 80s and 90s, where I just born, but I still know, and old days China opened up, right? And people are dream to go to China. One thing they said, you will get a big fortune when you go to China. Why? They said if everyone in China give you $1, then you have how much? 1.4 billion. Okay, that is that's everyone said that. I mean, in Hong Kong old days, but probably you don't know. But that's what they said. Everyone said, go to China, make about a lot of money. Just everyone give $1, you get very rich. Okay, so what's that? This. Okay, even charge $1. Okay, you charge $1. You earn $1 from each guy, means that the price is very low. It still doesn't matter, right? But you have aggregate income, right? You have 1 billion. You have 1 billion people multiply, right? And the aggregate income to GDP is also looks good. I mean, doesn't really look bad, the GDP, right? It's not a problem. Okay, the problem is this guy. Distribution of incomes, right? So it's a lot of, I mean, definitely now mainland China has a lot of middle class people, right? But according to the premier, right, we have more than, I don't know, 0.4 billion people. Their income is below 1,000, right? Or for several thousand, right? So this is rather important, right? So, but anyway, now you know that, I mean, a lot of people in Hong Kong doesn't get rich, right? I mean, even though they said everyone give you $1, right? Because this. But anyway, I hope this will make sense to you. Now the firm, we have J firms, okay, and they will use N input, okay, was W and WN, and the supply function is QJ, okay, and PW, and this profit function is this. Because this is coming from the last topic, right? And do note that we assume the price taker in the factor market, so W is exogenous, okay? So this is determined in general equilibrium, okay? That is the main thing that is being missing here, okay? General equilibrium will require you to simultaneously determine P and W. Is that clear what is partial equilibrium in general? Just basically this one, okay? This is taken as exogenous, okay? And we also take Y here. Y is also exogenous for the consumer, right? So why consumer has income, okay? It's not some money coming from the heaven that's dropped here. No, right? You have to work, right? That's why we all here, right? Why don't we just stay in the beach and drink some orange juice and have sunshine, right? Because we need to work, right? So income is not falling from the sky, but here just assume income from the sky, okay? And you may ask who has this? Maybe your occupation is son and daughter, then your money from your parents, and that's it. Right? Otherwise, you have to work, right? In that case, that's different, okay? So income in general equilibrium has to be determined in the model, okay? Same as the input price, okay? So that's the two things that's missing from the model, okay? We just take it as given, exogenous. Now, I think it's rather clear how you individual supply, the same thing. Do note that the allocation is in this dimension, not up and down. It's left or right, okay? So that's the same thing. Is that okay? Now, luckily, we have the demand supply curve, okay? So the question is, okay, we would define, okay, we just define the equilibrium will be the price that they equalize, okay? And in the case that one is upward sloping, that downward sloping, they cut at one point, right? There's P star here. Okay, this is the equilibrium price, okay? And here we didn't say how the equilibrium comes in, right? We just say this price, this equilibrium. We don't talk about adjustment, okay? You may ask, what if the price is higher than the P star or lower? Okay, we don't talk about those. Okay, this is the first thing about equilibrium. We just say at this thing, this satisfies this, the equilibrium. Okay, this is a one level equilibrium. Okay, and the second level, you should ask yourself, what is the property along in this equilibrium? What is, if this equilibrium stable? Okay, usually we call stability. Is if the price is above P star, what happened? I think you learned it in your elementary class, okay? But I look at your eyes, it seems like I make a wrong assumption again. Let me do it. I don't know. Looks like, is it true that no one have taken the intermediate or principal? Or maybe just too long ago? Anyway. So this is Q, this is P, right? This is standard case, assume downstream demand, upstream supply. Remember this one, okay, this is always true when price taking. And this is partially true, but almost true when focus on one market, right? When this market is small, then it's okay, okay? So we have just said the following, right? Demand, supply, and what we just said is only one thing. This is P star, okay? And of course, this is Q star because they're equal, right? And we didn't say anything about what happened if it's not the case, right? Suppose, I don't know, someone comes in, okay, this is the price, okay? And everyone's heard this price, that's no problem. Everyone's happy, right? Because everyone get what they want, okay? The question, this is usually later you will see the game theory part. We also look at this. It's like, okay, this is the solution. Is this solution satisfy the condition? If yes, this is solution. This is equilibrium. We don't ask what happened if in disequilibrium. Okay, but in this particular model, the disequilibrium can be solved, can be understood. There's a mechanism that leads to this one because we have equilibrium in this complicated system. The question is how you achieve this equilibrium. That's an important question. I mean, in the real world, right, nothing is perfect, right? Because everyone is guessing a thing, and then is it something what we call the market will adjust itself, right? There's any intervention required to be there, right? Is there any intervention required to be there? Well, the answer is no, right? That is the main point of market system, right? Probably you know it very well, right? Suppose the price is here, right? P bar, right? In that case, the demand is this one, right? Supply this guy, right? And here the supply is more than demand, right? And in that case, you will know you produce more than what is there, then they have to fight, right? Okay. If it's in the jungle, what happened? They fight and one die, then they're done, right? That's what happened, right? In the jungle, I mean, there's some deer or some rabbit die suddenly, some rabbit hit the wall, hit the tree, then die. Okay, and two tiger comes in, okay, and see what happened. Okay, the two tiger fights, right, until one tiger die or run away, then the tiger get it, right? So that is non-price mechanism. That's true in the real world, right? Just like it's not often the case to adjust. Like look at a lot of cases. Look at the tickets sold for sport event, sold for concert, right? The price doesn't adjust, right? How they allocate, right? Just based on first come, first serve, right? Or who can wage more, right? Yeah, they can keep in stock, but there are many ways they can fight, right? They can kill each other, right? So that happened. I mean, of course, I mean in the world where we don't have jungle, right? There's a law and order, okay? That's why they cannot kill. Then what they can do in this model, or in this case, what can they do? Just lower the price. They don't produce, right? Some firm is not producing and then just drop because they cannot sell. Of course, you can say if they can keep the inventory, they can wait. But if the inventory cannot be kept, or if even they kept, doesn't really matter. Other guys will sell, right? So that's why the price will go down, right? And someone will sell lower price, and the lower price will be bought by others, then go down eventually. Okay, but do note that the assumption have to be very careful when we make is at least we said in this world we have law and order. Okay, otherwise there are many ways to solve this problem, right? Just right is that where just imagine, right? I don't know, you watch TV, right? I don't watch TV. Actually, my mom watches TV. I think it's Zhang Ziyi, the Xiangyang Fu. This one, mom watch it. So you look at that movie. I mean, my mom always watch it, and I have to hide away. But anyway, in that movie, what happened is there's a girl is hunted by every boy in that movie. I don't know why, but every boy loves her, right? And they fight, kill each other to get her, right? You know it, right? I don't know, but looks like this. But that's what happened, right? I mean, they have to somewhat. Then so many people to supply love to that girl, so they have to fight until one guy die, and that's it, right? That's what happened, right? Unless you allow that girl to go with many boys, then they're fine, but you can't, right? So that adjustment. Well, I'm not making the fun, but just saying that this adjustment require a lot of assumption, okay, when we assume. But that's why you always talk about the market system have to be accompanied by law and order, right? If you don't have law, you don't have contract, you don't have those things, actually fails. And that's actually a lot of economics studying this, right? When you talk about there's no commitment, there's the information asymmetry, those kind of things kicks in, and that cannot adjust equilibrium, right? You may ask why a lot of time price is sticky, right? That's what happened. Why for unemployment? Look at the macro, right? Unemployment, exactly what happened, right? Because our wage cannot adjust downward, right? We have to eat, right? I cannot down to say I charge $1 for 1 hour, right? In that case, I cannot enough to eat, right? There's some limit I cannot go down, right? So sometimes that's why unemployment happen here, right? The wage is here, right? This demand for wage, but you cannot adjust that. Adjust somewhat. Someone has to be unemployed. Okay, but I mean, the reason you can adjust is because people are willing to adjust, right? And then could go down. But a lot of time cannot adjust. At least adjustment is very slow sometimes. So that's why at least temporarily there will be some adjustment. Like the real estate, you know, the real estate, you have the housing price, rental price adjust very slowly, right? But when you talk about stock market, adjust more quickly. Okay, and similarly, you have this idea, right? When the price is very low, right? You have demand more than supply, right? And you should raise the price for the seller, right? If you can't raise, then you can't, right? So have to be, I mean, these things are trivial, right? We talk about that in the intermediate class, but you have to know the big assumption here is price can be adjusted freely, right? And there's no jungle thing, right? Otherwise, it's kill, right? Is that clear? Okay. And yes. And just a matter of fact, usually you will see in the intermediate textbook, right? And you will see this demand supply. You can see short run average cost, long or marginal cost. But the long run is also fine. That will give you this much, right? Is the profit. Yes, because this is the average short run average cost. The difference is the profit margin, right? So this is the profit part, okay? And that means that in this model, okay, every firm is making some profit, okay? And why this short run? Because if you imagine in the model, in the case where there's no entry cost, okay, if the entry cost, this will keep as long run, right? If in the case there where you see some profit, okay, people will rush in and no one make any profit, right? That is what people will say long run equilibrium, okay? Long run equilibrium will be saying that beside this thing, we require one more thing, okay? Or we require that no one is making any profit, okay? Look at, it's easy to see right now. You go to Alibaba, Tmall, okay? You try to look at some generic product, okay? You will see a lot of competition, okay? Almost people said actually they're making zero profit. In fact, you try to check. Most of the seller in the Alibaba and Tmall is making very minimal profit, except you have some market power. I mean, if you're selling generic thing, it's not going to make anything. Just like iPad is charging a premium, right? But look at generic Android pack, almost like the price is so low that you can't believe it. I mean, how can they make this profit? But it's so low that it's almost making zero profit. Okay. Look at this assumption, assuming there's no entry cost. Okay. You enter, if you require substantial entry cost, which is the case in some cases, then the profit is at least okay to the equal It's at least the end is can be okay to be equal to the entry cost. Say maybe I write that down because looks you don't see what I'm saying. In this model, in the long run, if there's entry cost into this, right? You allow this to be equilibrium as long as the entry is lower than entry cost. That's fine. If the entry is if enter the industry cost C, okay, this is still equilibrium. Okay, the profit is because you enter. I mean, it's not making main profit. It's also fine. Okay. Actually, I have. I mean, if I don't know how to say, because you have to be. If you really want, have to be very. Anyway, I don't want to go. The reason is, if you really want to be very careful, you have to say your profit have to be depend on the set of J, and you make sure that the extra guy comes in, right? J plus 1, P, J plus 1 is less than C, then you will not enter. But I don't want to go into that detail because you will learn it when you do game theory. So I just try to be lazy here, okay? Assuming that would happen, okay? So okay, but you can imagine the profit already include the entry cost, so I think it's fine. Okay, this assumption still roughly okay. When this you assume the profit include all the costs you are doing is long run is not as long as this long run average cost, because long run average cost include the entry cost. In that case, that is a fine thing. Okay, so the reason is being that if your profit someone comes in, right? So the long run model, okay, what is relaxing in this model is you relax the number of firm. Okay, as we said in the upper here. Okay, before we said the number of firm is fixed. Okay, now we allow number of firm is relaxed. Okay, you probably would jump up and say, is the number of consumer and exogenous, right? And in most of our case, we can assume number of consumer is exogenous. Okay, but when we talk about family economics, we talk about production, reproduction, and fertility problem, that the number of consumer is not, or in the macro population growth is not exogenous, right? Right. And recently, people said this is our last generation. Thank you. So it means that the number of consumer is shrinking, right? Actually, a lot of place population level is shrinking. So actually, the meaning of the macro, or in terms of business prediction, right? Because usually we predict the population is growing, but as you know, in economic theory, empirical would tell you that having a baby or a kid is more like the initially it's a normal good. So yeah, it's normal good, right? But when you get more richer, you become inferior good. Okay, I don't know why, but happen to be the at least for the modern woman, they would think usually they think traditional woman would think more kid is more happier, monotone. But when they are getting richer, there's sometimes substitute, right? Having baby may not be fun. Okay, some baby is okay, it's an optimal level, but there's some other good that can substitute. So so that's why the fertility goes down. But anyway, that try to explain what it is. So that's why we don't have endogenous number of I consumer, because in terms of the horizon we're studying, okay, we can safely assume population is fixed, right? But for some other model may not be the case, right? Number of consumer may not be fixed. Okay, and well, that can be true because not even population, because the market expand, you can attract more consumer outside what traditionally you have, right? So so that's why there's some issue here. Okay, consumer may not be fixed when you talk about long run. Say, I think in the old days you probably notice Alibaba or Tencent, they expand so crazily, something unrelated to what they are doing, right? They keep doing business A and go to B and then C, D, E, F, G, right? but of course now the central government don't allow them to do it. I mean, but if you try to model them in the old days, you have to consider consumer base is not really fixed, right? Because they laterally expand the business, go on and get bigger and bigger. But now, I mean, they are not allowed to do that. But that's another issue. But that means that number of consumer can also be endogenous because the market is expanding, right? It's very often the case when you do IO model. Actually, you would do is you would allow endogenous consumer base also, right? Because you may think this is the consumer you're doing, but when you say lower the price or do some advertising effort, you can improve more. So even that is not exogenous, okay? So when you have long run equilibrium, you allow firm to enter, they make zero profit. At the end, you get this in the graph. This is, I think, this familiar from your intermediate or principal class, right? This is the condition, right? When you have demand and supply, right? And this is the firm level, right? Indeed, you should learn from your first course, learn from our first class, right? We also have something. Anyway, so don't join, but forget about it. Okay, that will be enough. I'm going to talk. So that would be the case, right? So is that clear? So I want to end ourselves with monopoly, I guess. At least we focus on something a little bit more interesting. Maybe five minutes, I think is enough. So now, if firms are not price taking, there are many scenarios. It's possible, okay? And basically, all the IO, the whole IO literature, at least half of our literature, will focus on at least one firm. Talk about only single firm, okay? Only one firm is doing that thing. Even though you think more than one firm is interacting, focus on single firm is very useful benchmark, right? And at least in the local, you don't change that much, focusing on you think the interaction is limited, monopoly is a good one, okay? And turn out to be, this is when you solve a lot of model, you see in the literature, the paper, they will first solve the monopoly case and then go to duopoly or oligopoly. And this is the reason is being that this is the simplest thing you can do, right? Because in that case, you don't talk about game theory. Okay, so basically just like we try to solve the problem without going to game theory. Okay, and because only one firm is in the market, he just solving maximization problem. That's very simple. No need to use game theory idea. Okay, so in that case, the price test setter. Okay, he decide the price. Okay, it means that he is facing a downward sloping demand. Okay, that's what he have. Okay, he can pick any point in the demand curve. Okay, any point is possible. So now you can see why we don't have supply curve, right? Because he set the price, he decided the price. It's not what supply curve. You give the price, what can supply, right? It's not the case because he decided the price. Okay, so that's why there's no supply curve. He can make what?
He can set prices.
Yeah, he can set prices, but it's not he is not given the price what he's going to supply. So supply curve is like this, right? Given the price, what is the quantity supply? But in the monopoly, yeah, he decide exactly what the price is. Yeah, it's not a function of the quantity. Okay. Now, here is the terminology. Okay. And what we often draw is an inverse demand curve from demand curve. I think I emphasized it now. So demand curve is P of Q, inverse demand is Q, demand curve is Q of P, inverse demand is P of Q. And then we focus on inverse demand curve usually. Okay, just to remind you the terminology. Okay, but also usually we are just very lazy. We just still call it demand curve. Okay, but just make sure that you be very careful. Okay, don't make mistake. Okay, so I think we have this in the last chapter. So I think there's some slightly change in notation. I'm sorry, but I think I followed the book, right? Before we use Y as output, but now I certainly change to Q because Y is reserved the income. I don't know whether it's good notation, but I think the book uses it. Okay. So here this is a simple question, right? The maximization is just quantity, right? And this is standard thing we know, right? Just we have seen that, right? We just seen that. And this is exactly what we have discussed in the previous topic, right? Which is the marginal cost equal to marginal revenue, right? And in particular case, if this is 0, then price equal to marginal cost, right? So when every firm is price taking, right? This is gone, right? So this goes back to the perfect competition. So in this model, I also take care of perfect competition, right? Because if this is a flat line, right? So now we will try to see something, okay, here. So the marginal cost, as I said, you can write down as price times 1 over elasticity, okay? So I want to emphasize one thing here is the left-hand side is marginal cost, which is positive, right? So this is 1 plus 1 over, okay? And this is positive, right? So this guy must be less than 1, right? Cannot be bigger than -1. Otherwise, this whole term, maybe I write down here. So we need 1 plus epsilon q greater than 0, right? Because positive, marginal cost, right? Positive. This guy must be positive, right? So you can have this, right? And then wait, let me do it slowly. Oh, no, I don't need to do it. Okay, this is fine. Okay. So I want the inverse is bigger than -1. So no, wait a second. So okay. So but this guy is negative, so I just focus on negative region. So this epsilon, right? Okay, this is must be less than -1 because -1 is -1, so it must be here. Okay, so that's why we have when we have monopoly, we have elastic demand. Okay, so let's go back to the idea why we focus on elasticity is because of looking at whether we have monopoly. Okay, we should see the elastic demand there. Okay, so that's why this is the case. Sorry for slow here. And last slide, okay. We have that already in the last slide. Is the markup ratio is inverse elasticity of demand. Okay. And later we talk about Carnot next class. We will see how this changes. Okay. And actually this is the reason why we do how antitrust do things. Is because of these formulas. Can justify a lot of measure. But I don't think we go here today. So thank you. I will see you next week. So make sure that you enjoy the National Day and then remember the homework.